Hello, this is Steve Groven, and the topic today is force. Now, if during the video you need to pause me, restart me, or even just fast forward me, that's fine. I do not mind. Just make sure you get all the information. Okay, so let's start out with a general definition of force, and we're going to go with a very basic physical science definition. It is basically a push or pull exerted on an object in order to change the object's motion. Now, there are several different effects that could occur as a result of a force. First one, obviously, is movement of a stationary object. Let's take, for example, the common couch potato. Now, if somebody is behind the couch potato and decides to move him or push him, then you could cause a little bit of movement. Okay, so another one is a change in speed. Like, for example, if our runner here decides that he wants to go a little faster, if he exerts a little bit of force, he will change his velocity, okay? The other one, a change in direction. Anybody going around a curve will notice a certain centrifugal or centripetal force on the car as it is going around a curve, which in some cases could cause the car to, well, skid along the sides like this one. But what we're really looking at is it takes a force in order to change that car's direction. And another possible effect of force is a change in shape or size. You're hammering a nail. You miss the nail. You hit your thumb. You are going to change the shape of your thumb. Okay, let's continue on. Now, some of the types of forces, and there are four fundamental forces. They include the strong forces, the electromagnetic forces, the weak forces, and gravity. Now, strong forces include the nuclear forces that hold the nucleus of an atom together. They're the strongest force of all the fundamental forces, but they do not really extend very far. So, as you know, our atom consists of protons and neutrons, and the strong nuclear forces is actually what keeps everything together. Okay, now let's continue on. Electromagnetic forces. The name itself kind of explains what it is. Basically, we're talking about magnetism and or electricity. Now, weak forces, these are the forces that are kind of the cause of radioactive decay. And then the last of the fundamental forces includes gravity. And speaking of gravity, let's talk a little bit about the Newton. The Newton is called our SI unit of force. And the Newton basically is just an N, just your basic N. 1 Newton is defined as the amount of force it takes to change the acceleration of 1 kilogram of mass by 1 meter per second squared. Which also leads me to the definition, or the mathematical definition of a force. The formula is your force is equal to mass measured in kilograms times the acceleration of any body. We'll be talking about that a little bit later when we discuss gravity. Okay, and I'm going to move on. Sorry about that. Okay, so the next part of the topic that I want to get through today is the definition of the net force. Let's take our couch potato again. Now, there's going to be a couple of forces that are acting upon that couch potato. Gravity, whoops, sorry about that. Gravity, for example, is going to be acting upon the couch potato. Force due to gravity. And there's also another force that's actually pushing up on the couch potato. I'll explain that a little bit later on. But in some cases, that is considered the normal force. Now, we'll discuss normal force later on when we talk about inclined planes. You could also have another force acting upon this couch potato. Say you could have the angry neighbor or the angry stickman pushing the couch in one direction. And of course, we could also have another force on the couch potato the other angry stickman pulling on the couch potato with the rope. So in that case, we'll have a couple of extra forces. One force pulling the couch potato, and another force pushing the couch potato. So in this case, we've got 4 forces that are acting on the couch potato. Now, these top 2 forces, this one right here and the bottom one, well, if the couch is not rising or sinking, then we can say that those forces are in perfect balance. On the other hand, we've got 2 forces that are pushing on the couch, and if there is any movement, then we're going to have an unbalanced force going in a specific direction. Okay, let's talk a little bit about let's talk a little more about balanced versus unbalanced forces. Now, if you have a balanced force, then the net force of the forces is 0. If you have an unbalanced, then the net force, or the addition of all the forces, is not going to be 0. Let's take our couch potato up here again. Now, this time, I'm going to add 2 stickmen on either side. The first stickman is pushing the couch, trying to get the couch out of the way, and the second stickman is pushing in the other direction. If both stickmen are pushing on the couch with the exact same amount of force, then what we have are balanced forces. The net force is 0. Say, for example, the first stickman is pushing at an exerted force of, well, let's say 15 newtons, okay? So if he is pushing on the couch at 15 newtons and the other stickman is pushing negative 15 newtons, anytime you're going to the left, you are negative, and anytime you're going towards the right, you are positive. So 15 newtons and negative 15 newtons, if I add those 2 together, then the net force is 0 newtons. Okay, so let me clear that out a little bit. Now let's take another instance. Let's say that the guy on the left, well, he's just a little bit bigger, and he's pushing the couch just a little bit harder. So the net force in this case is 20 newtons. And the other guy pushing to the left is pushing at the aforementioned 15 newtons. I'm going to put that up here again, or negative 15 newtons. So 20 newtons minus 15 newtons means we have an unbalanced force of 5 newtons pushing on the couch. And in this case, it's a positive 5 newtons, so the couch is moving 5 newtons to the right, or it has a force of 5 newtons pushing it to the right. All right, let me clear that again, and let's get another possibility here. Now, let's say the first guy on the left is actually quite a bit smaller than the guy on the right. Let's see, shove him right there. Okay, so let's make this one let's make this guy 7 newtons. He is pushing 7 newtons to the right, whereas our other guy is pushing still negative 15 newtons to the left. Now, hopefully you remember addition and subtraction of integers. 7 newtons minus 15 newtons means we have a net force of negative 8 newtons. I kind of got off my screen there, sorry about that. But the net force in this case is negative 8 newtons, and we have an unbalanced force going to the left. Okay, so let's recap. A force is going to be a push or a pull that changes the motion of an object. The formula for force is equal to mass times acceleration, and a net force is the addition of all forces upon an object. Now, if you have unbalanced forces, the object will move, it'll change acceleration or change direction. If you have balanced forces, then the object will not move, It will stay in place. It will not change direction. Okay, thank you for listening, and I have run out of time.